There's a teapot on an incline here, and there's an applied force of 15 newtons pushing down perpendicular, okay, to the surface. Well, let's draw the forces we know for an incline. Straight down is force gravity. And of course, we will then break that into the triangle that we know, x and y coordinates for that. And then straight up from the incline, of course, would be force normal. And let's put some labels on that. So this is force normal here. This is force gravity y. And the vector here is force gravity and force gravity x. Let's look at force normal this time. Usually normal force on an incline is equal to force gravity y. But now we have an extra force, let's call that F, that's pushing straight into the incline, perpendicular to it. That's increasing force normal. Remember that normal force is the reaction force along an incline as to how much the object weighs on that incline. Since there's an applied force pushing down on the teapot, the surface is going to think that the teapot weighs more than it actually does. So it's going to push back more. So that's why force normal is force gravity y plus force applied. Now on the incline, force gravity x will pull down, try to make the teapot pull down, but force of friction is going to oppose that motion downwards. Okay, so that's what it looks like so far in this diagram here. Let's do a force net equation. Force net is going to equal then force of friction minus force gravity x. Okay, let's solve for force gravity x. So force gravity x is going to equal, the value of the mass here, a little bit hidden, is 2.6 kilograms. So it's 2.6. We'll multiply that by 9.8 and multiply that by the sine of the angle, which is 34 degrees. Okay, so we can get a value then, okay, for force of gravity x, okay, from that, and that equals 14 newtons. Now if we look at this right here, since we're looking at the minimum force here to prevent it from sliding down, force net's then going to equal 0 since there's no motion. And therefore, force of friction minus force gravity x, okay, will equal 0. So what that means then is force of friction is going to equal force gravity x. Okay, now of course, force friction is force normal mu. That must equal force gravity x. But normal force is force gravity y, okay, plus that force. Okay, so let's go ahead and do that. We know it's 15 newtons is the applied force on there. So then we're going to go 2.6, okay, times 9.8, multiplied by the cosine of 34. Okay, and then we have to add 15, because that's the applied force. Let me put a bracket around this, and multiply that by mu, and that has to equal 14 newtons. Okay, because the friction force equals the force gravity x. So the mu then has a value of 0.39. And that's how you find it using this particular system.